So now we're going to look at a specific example problem, look at some specific points on our line and the values of the points in different places. So here we have some function, it's f of x. So it's a parabolic function given by this equation. So it's minus x minus 2.5 squared plus 6.25. And so if we wanted to plot f of x versus x, this is what it looks like. It has some curve, it has a maximum at 2.5. And so we can then, like before, we can refer to specific points. So we're going to look at our points at 5 different points. We're going to look at it at 0, 0.5, 1, 1.5, and 2. And so here, this is going to be our x1. 0.5 is going to be x2. This is x3, x4, and x5. And so just like we had shown before, we're going to have different points. So what we're going to do is we're going to start building up a table with our different values. So our table is going to have 3 columns. We'll have we'll have 1, 2, 3, 4, and 5. And then we'll have our value of x for that given I value. So the value of xi when I equals 1, so this is x1, and you can see that this is just equal to 0. We can also do it when x for the value of x2, this is 0.5, x3 is 1, x4 is 1.5, and x5 is equal to 2. So this gives us our list of x values. Now we want to know what the value of the function at those points. So this is going to be f of xi. So we can do this 2 different ways. One, since we plotted it, we could figure it out graphically. So we'd see that x1, it's equal to 0. Or we can start plugging in our values of x into this equation. So if I plug in 0.5 to my equation up here, we find that, okay, the value of this function, this is just equal to 2.25. If I plug 1 into my equation, so that gives us, this is 2.25. Now we plug in this 1. This gives us a value of 4. So f of 1 is equal to 4. 1.5, 5.25 is our value of xi. And then this last one is equal to 6. And so this is how we can, for a specific function, we can build up our arrays of the x values and the values of the function at those points. And then we also are having the list of what our different I values are. And so like before, remember we can identify specific points. So we're going to look at a specific point. So we're going to look at if I is equal to 3. And so if I is equal to 3, then we're going to look at, so then we know that xi, this is equal to x3. And so from our table, this is just equal to 4. Oh. That's not equal to 4, that is equal to 1. We can also refer to f at xi. This is just the value of the function at x3, so this is just equal to 4. Like before, we can refer to the points on the either side. So we can f of xi minus 1. Oh. So we want to figure out what this value is. So we know that xi minus 1, this is just equal to, so it's equal to x2, and we see that x2 is equal to 0.5. We can look at xi plus 1. This is x4, and that equals 1.5. And the final thing is we can know what are the value of the functions at these 2 points. And so we find that f of xi minus 1, that's just equal to f of 0.5. And that equals 2.25. And then at I plus 1, this we just do the same thing. So it's f of 1.5, and that just equals 5.25. Where in this, you can see our x values, they change by 0.5 each time. So we can see that our delta x is equal to 0.5. So what we'll do next, we can start doing with these values, is we'll see that they're related to our derivatives. So that's where we're going. We'll be able to use these values of our functions for our derivatives, but we need to know how to find them.